Hello there. I'm going to be talking about the Agent Hub, library slash framework I've been working on for a while now to make writing agents and deploying them and using them easier. You probably heard me rumble about this for the last few weeks, so I think it's time that I show this properly, and it's good timing. It's at a good time it's at a good spot to show it already. Okay, to illustrate my point, we'll start with a hypothetical. Picture you are the tech lead at Law Firm Incorporated, and you've been tasked of building two agents. A small, simple agent that lives on the firm's website. It's supposed to help possible customers, potential customers, on what the firm does, what proper department they will be routed to, how they can help. So it's fairly simple. But then the firm's been having it's been missing on some revenue because the big clients are taking most of the lawyer's time. There's no bandwidth for smaller requests that smaller customers might have, like some paperwork review, contracts, etc., etc. I'm making this up. I have no idea how an actual law firm works, but you get the point. And you're tasked on building these with some. This agent is supposed to have access to internal tooling and maybe internal databases. So you have to start planning. There are many ways you can go about this. There are many libraries. The most famous one would be the AI SDK, which solves the problem of calling the LLMs, makes it very simple, has nice APIs. They somewhat just started doing more agentic stuff, which is the loop of calling an LLM. The LLM has some tools, decides to call these tools, you execute them, get the output, feed it back to the LLM, and repeat until it decides to get an answer. But then there are other options. They don't solve for infrastructure, so you would need to know how to deploy or where to deploy. There are other libraries that I'm not going to get into besides the Agent SDK, which is what Cloudflare offers. Has very nice infrastructure because it's built on and it's deployed on the Cloudflare network with Drupal objects, which offer per agent compute and storage. There's MCP support out of the box, both for client and servers, but they're very basic primitives, which means you have to write most of the agent engine and runtime yourself. But let's say, you go with the Agent SDK. You've heard good things about it. You most likely already had some of your infrastructure on Cloudflare, so you trust them. Good, it's time to plan. Okay, maybe first question that comes to your mind, do I need MCP? I've heard MCP a lot. How different are the two agents, how much I can share between them? How do I interact with them? How I call them? I've read that I have to deploy a worker. Do I have to be in the same worker? What is a drawable object? A lot of these questions might come up. First of all, let's get to the MCP. In this case, no. MCP is very nice if you want to write your tools once and then you allow any external agents to connect to it. So in this case, for example, you would maybe you want to have some of this internal tooling or access to this data that your firm has and allow any external agent, your customers bring their own and connect to it. In this case, you don't really want that. You would be missing on the potential revenue because you're basically giving this privileged data away. And this would be for the legal review agent. The chat agent doesn't really need any special tooling besides maybe a tool to query some knowledge about the company and the department and so on. Which means, long story short, you have to write the agent yourself, the loop, and all that comes with it. So no time to lose. You start reading the Agent SDK docs, and you piece together the whole actor model idea and you like it, you see there's an agent class, and you kind of see that every method that you add to it is kind of the action space of the agent, that this actor that can call these methods, and that might look very nice, but immediately you then realize, okay, but how do I call this class? Well, in fact, the agent or this durable object is just one piece of the puzzle. You also need a worker to deploy this. And the worker is the HTTP entry point, roughly, to the Cloudflare's edge. And from that worker, you can start dealing with the agent, which means you're going to have to handle the HTTP or WebSocket routing to your agent yourself. Then you'll notice that there's no LLM solution. You have to implement your inference, calling any provider yourself, which maybe gets you thinking again, oh, do I need to go back to the drawing board? Or maybe I can just use the AI SDK that we've mentioned before that solves this or makes it very easy. That's one. Then the agent is going to need to do a lot of tool calling before it comes up with an answer. Which means you have to write that, but be careful because there are some rough edges that you might encounter. For example, if the agent calls a lot of tools on that loop, you might encounter a sub-request limit on the worker D runtime, which is just a limitation to avoid either infinite loops or one durable object doing just too many requests to the outside world. Also, if you leave your loop running for too long and there's no client connected to it, the durable object might get evicted. We'll talk about this later. That's one thing. You also want to have proper debugging and tracing. You want to have visibility into your agents and what they're doing. So you also have to write that yourself. And then the testing of these agents that you're going to be writing, there are multiple models that you can go with, and all of them are going to have different capabilities. So you need to test different models, see how good they perform with your setup. So you want to be able to do this fast and iterate. You don't want to have to redeploy every time you want to change a model. Okay, now this kind of illustrates my point. I would love to be able to write agents in a simple way, just prompts and tools, and there's this whole runtime that's solving all the infrastructure for me and the headaches. I would love to have the tool interface like the AI SDK has, which is very simple and it works great. This long run-on tasks for agents, I would love that to just work, so I don't encounter infrastructure errors along the way. While I would love for this to solve for me, I still want to be able to have flexibility and extensibility into this kind of runtime if I want to extend it somehow. I want to keep all the benefits of the Agents SDK already. I don't want to miss any of those. And since I'm already asking for things, I would love to have scheduling so my agents can run on in the future without any client having to connect to them with alarms or on a timely basis. Tracing to be included. File system is shown to work great, so I would love that to be available, etc. And here's when I come to tell you on something that I've been working on, which is this repository right there that you can access, the Agent Hub. And there are a few pieces here, but most importantly, it's the runtime. It is a fully managed agent runtime that handles all the infrastructure quirks that you would face if you try to do this all by yourself. There are a lot of details that one might miss on the Cloudflare platform if you try to naively implement some of it. So it's written by Cloudflare experts, so you don't have to be one. And as you run this runtime or you deploy it, the result that you'll get is a worker that exposes some HTTP endpoints or with WebSockets as well. And we also offer a TypeScript SDK that easily allows you to interact with it. You can also, of course, use the endpoints directly, but that comes out of the box. And then I also, to illustrate how extensible and what you can do with it, there's a debugging UI that's not really tied to the runtime. It's just a React app built with the client, which means you can not use one. You might just want to use the runtime headlessly from your other applications, from your backend, or you might want to write your own UI for this. But it's at least it serves to illustrate what you can do with it. So let's get back to the scenario that we're talking about, and let's see how long it would take us to write an agent, at least start iterating with it. So if you go to the repository and you just clone it, the only thing that you need to do is create a blueprint and a tool. A blueprint, consider it as a template for an agent. What that might look like is you drop a file in Hub Agents chat agent, and you start writing the prompt, and then you give it a name, a description, the prompt that you just wrote, and the capabilities. These are the tools that this agent or this blueprint will have available. Not just tools, plugins. Plugins are something that I'll get into it in a second. And then the only second file that we really need is the tool itself that we just referenced. So we'll go to Hub Tools and dump this file there. We can see there's a tool import from runtime, which has the same interface as the AI SDK, but it's so you can just port over all of your tools. But we also have extra arguments in there that you don't have to use, but allow you to extend the whole runtime even more if you need that. And once you have that, you run npm run def, and the runtime is live. You can just connect to it. So from any application, you can just import the client and use it as you see here. There's this notion of an agency, which you can just picture it as a namespace or a project that you can create. So you can put all your agents inside of there. It allows for multi-tenancy, or a better way to organize everything. Just I included it here to illustrate some of the capabilities. Also, there are variables that you can set on an agency level, also at a global level, but I was just trying to show what you can do. And you can see that once you've created your agency, we can go and spawn an agent, and the agent type is chat agent, which is the exact blueprint that we just created. And once that's done, we can just invoke that agent by sending it a message. We never have to, from our client, we never have to keep track of all the messages that we've sent. Those are always available inside the agent. So no more sending back and forth the complete array of the conversation. There's a lot more that comes out of the box. A few of the screenshots here are the UI that I've built, but it's basically to show everything that's included. You can see the blueprints. You can see tracing is out of the box on the right screenshot here. There's a file system, there are plugins, schedules. So on your agency, maybe you have an agency for your analytics agents. This is an example that I'm going to show in a bit, where I have a few agents that look up some of the analytics on my websites, and they run once a day, and then they build a report for me. So this agency just has a schedule for that. Yeah, that's it. So now let's get into how it works and demystify some of it a little bit. Well, it starts with the loop. Okay. This is as simple as I could put it, I think. The agent just works like this. You have an input message, and then with that input message, you're going to call an LLM. This LLM might have some tools available to it that you've given it access to. And as the LLM reasons, there are two possibilities that it might output. It can either decide to call some of those tools, and in that case, what you're going to do is you're going to execute those tools, get the output, and feed it back to the LLM, and iterate again. And you'll do that until the output is not a tool. Instead, it's text. The LLM has decided that it's done everything that it needed to do, and just giving you the final output. The problem here is that the LLM might decide to do an undefined amount of tool turns. They could be 2, they could be 500. And here, this is the source of the issue when we have long-running agents that might decide to spend 100 turns just calling tools, which can get long, and this could get too long for our infrastructure. But let's see, okay, how do we put this loop into a durable object? If we are naive enough, we are going to get a few issues. First of all, you're going to need to have an agent, a client connected to this durable object, because otherwise, if it gets too long, as we've mentioned before, the durable object is going to get evicted, which is bad. Then also there's a different issue, which if the LLM decides to call too many tools, which end up doing too many requests outside this durable object, there's a limitation in the runtime that we don't want the you to think about. But if you hit that limit, your durable object is also going to get evicted with an exception, which means this implementation is a little bit too naive and it will not work if we want to have agents in the cloud. So let's just engineer it a little bit and have a state machine do it. How do we do this? Well, durable objects do have alarms or some sort of scheduling built in. So what we can do is have this loop be tick-based. How it will work is, as we have an input message, we'll immediately store that message in the durable object storage and immediately schedule the next tick to run. And then as that tick runs right after, that calls the LLM. If the LLM decides to call tools, we'll execute that tool in this iteration of the loop, store the output immediately, and as we store the output, we'll also schedule it for immediately the next tick. What this does with the next scheduling is that this resets the event of the durable object, which means the long-running process gets reset, and the limits of how many requests you do to the outside world are also reset. So this does effectively solve long-running tasks for agents. It solves the issue of having too many tool calls in your agent at one time. And also, the LLM calling is built in. Now you don't have to worry about that part of that layer of the agent problem. So this is not a trivial implementation. So what we do is we package a solution and we just give you access to it. Now you might think, well, if you build this for me, I might lose some of this extensibility that I want. And not to worry, you can see that there are some X's, green X's here at all these points. And all these points are hooks that you can hook into with plugins. That's what they allow you to do. So you can, an example of something that you could do, a plugin would be a human in the loop plugin. So consider the LLM has access to tool A, B, and C, but tool C is risky, and you would like the human to review that before we actually execute those tools. So you can have a plugin that hooks right after the LLM outputs a tool, and the plugin checks if the tool that the LLM decided to call is tool C, and if so, you can halt until a human approves. There's much more that you can do with this. This is to kind of illustrate that you still remain completely in control over how the whole thing runs. Okay, well, that was already taking quite some space on my screen. So to show how much the Agent Hub covers, I am going to abstract a little bit of this. So we'll clarify an agent, which is still a durable object, has this state machine in it. And what also makes it an agent is, first, we'll need an ID to be able to address this single instance of an agent, and then the storage that allows it to remember and run the whole loop. That's for the agent, but you might want to configure it yourself. You might want to give a special system prompt or tools so the agent loop behaves in this a specific way that you're interested in, besides plugins that I'll ignore now. Okay, well, now that we have this, how does it compare to the Agent Hub? What are we doing? So we're actually not storing and not defining tools inside every agent. In fact, don't get scared. This is sort of how it looks like. So let's start at the center. These are all agents. And instead of having the tools defined in tools and plugins defined inside each agent, you're going to write your tools and plugins once, and they're going to be available in the entire hub, in the entire project. And then what all your agents are allowed to do is register which ones they're interested in, and they will run only with those available to them. You can see that all these agents are inside an agency, and that's the namespace that I was talking about before. They are completely separated, so two agencies are different. That's the multi-tenancy solved. Then each agency can have different blueprints defined to them. The blueprints are just JSON, which means you can add, edit, or delete them at runtime without having to redeploy it super fast. And then you can create more agents using the new blueprints very, very, very quickly. One extra thing is that all of this has an R2 bucket acting as a file system available to it, which is a very nice abstraction that we found is very important to have, and R2 is super reliable, which just works great. So this is most of it. This is how it looks like. Most consumers don't really need to know all of this looks like that. The whole point is abstracting all of this away, so people and users only have to think about prompts, tools, and that's it. No, maybe plugins. Now it's demo time, so let's show what this can do.